Hi, my name is David Loken. I'm a mechanical engineer and I work for Hatch here in Saskatoon, and I've been here for about 12 years. So Hatch is a multi-discipline engineering firm. Our job is to help clients across Canada and actually across the world to develop engineered solutions to problems, whether that's something in infrastructure like a road or a bridge or a port, or for our clients here in Saskatchewan who are mostly mining clients, we help them design a new mine or modify a new mine or just make it work better. So mechanical engineering is basically things that move. So the mechanical engineer, he worries about a piece of machinery, whether it's a conveyor or a crane or a lift or something that is used in process that breaks things up or screens out debris or whatever it is, but it's a physical piece of equipment that we have to figure out how to mount it, how big the motor should be to run it, how to make it so that it doesn't vibrate too much, that it fills its technical requirements.
My name is Mattea and I'm an engineer in training here at Hatch. A structural engineer is really any structure, buildings, bridges, hospitals, houses, like any of that. But here at Hatch, we mostly do industrial type work. So in the mining space in the region, mining's a huge business here in Saskatchewan. So most of what I do and what our group in this office does is either upgrades to existing infrastructure or expanding onto existing buildings for new processes for our clients.
My name is Jayden Ladebruk. I'm a mineral process engineer in training here at Hatch. As a mineral processing engineer, our mineral processing group, we do a lot of modeling, simulations, calculations. So I guess just from like a project standpoint, there's different levels of the projects, FEL 1 through FEL 4. And some of the earlier projects will be more of like conceptual stuff. So a client might come to us and say that they want to know if a project is even going to be feasible. So they'll ask us to just kind of do some of the preliminary work and look at, if they purchased all the equipment and if they were operating it and they were wanting to produce this much per year, what would that actually look like? Would they make money? Would they not? Would there be any sort of environmental setbacks? Would there be, just all of these different aspects that we have to take into consideration? And so my group specifically, we will take whatever data they have on the ore that they are collecting or just kind of the raw materials and put it through simulations to say like, for this process, you're gonna need this many pumps, you're going to need to do these kinds of processes, you're going to need to screen it and kind of provide all of that data to them, and that helps determine then the other disciplines what they need to do. So mechanical will then be able to determine the size of the equipment that they'll need, and then that'll then tell electrical what they need to do. And so my group specifically, we're more at like the front end of a lot of those projects.
So my job is to get a group of people together and say, okay, we all have to work together. Some of the jobs are quite large. Obviously, one person can't do it all by themselves. So you might have 5 or maybe 1 or 2 or maybe 10 or 20 people working on it. And somebody has to coordinate that and make sure everybody's working together, that you're talking to the right people, that you're not sitting there scratching your head because you don't have the right information, that they're efficient. So my job is to mostly help them do that, because I do some detailed design, but really there's lots of other people that can do that. I just help them.
So up to this point, I've kind of spent 50% in the office and 50% on our client sites. So while I'm in the office, I'm either building design models, like analytical models, testing, different layouts for buildings and projects and stuff like that, or meeting with project teams and with our clients. While I'm on site though, a lot of my time is spent doing structural inspections. So that means I'm walking around the actual buildings, maybe things that we've built in the past, and making sure that they're still safe and that they're still doing what they were designed to do.
So I went into engineering first year, took a few chemistry classes, really enjoyed those and kind of continued on with them. And then, decided to do chemical engineering in school. I did a 16-month internship between my 3rd and 4th year out at a potash mine just outside of Saskatoon here, and I really enjoyed it. I didn't know anything about potash prior to that. I didn't really know a whole lot about the mining industry really at all. So that really piqued my interest. And then after school, I worked at a different company for about a year as a junior project manager. And although that role was, I think it was still beneficial to me, it wasn't necessarily what I wanted to do in the long term. I wasn't really doing any chemistry or any of the things that I really enjoyed in school, but it did kind of give me a taste for what the industry after school was like. And then this position at Hatch opened up and I applied for it and I got the position and been working here for a year and a half, almost 2 years now. And I've been really enjoying it. I get to work on all sorts of different types of projects, work with different commodities, so like potash, gold, copper, whatever the project may be that comes up. I've been really enjoying kind of that variability between projects and the variability between like the different roles that I have within a project too. It's been really good so far.
A typical mechanical engineer is somebody that kind of likes working with their hands. You know, a lot of people that are electrical engineers or computer engineers, they're more into the computer side of things. Whereas the mechanical engineers, a lot of times they've grown up working on cars or building things in their basement. Or the idea is that you like seeing things get built. You like being able to touch it and feel it, see it in place. And that's the excitement that a mechanical engineer, well, maybe any engineer gets, is see it in the real world. It's all well and good to say you've designed it, but to be able to physically see it work is ultimately what we want to do.
In terms of skills that are needed for structural engineering and just engineering in general, the first thing that pops into people's minds is they need to be really strong in math and science. They need to, you know, have all the math down and be really good at physics or something. And at a surface level, yes, those skills are required to get through the post-secondary education and things like that. But I think more than anything, and it's way more noticeable once you get to, you know, the actual profession in industry, you need to have the ability to solve problems, to, you know, handle stress. There's things that pop up all the time and it's like, it's not a black and white answer of, oh, I can do this calculation and get this answer. You need to be able to sit and think about it, realize that there's not always one right answer, and you need to be able to effectively communicate that with your teams and with clients.
You just have to be driven. A lot of people think that you need to be smart, you know, you need to be top of the class. But a lot of times, even just talking to people around the office, people that I've met in university, a lot of times they weren't the top of the class. You know, there are the odd person who was, but a lot of times it's just having that determination to actually, you know, push yourself and study hard. Because yeah, the first few years of university for engineering are quite difficult. They can be a little bit taxing, but I think as long as you have that drive and determination and you start to build that support system for studying and having people to ask questions to, it's a huge help. You can do whichever discipline, whatever classes, you can do perfectly fine in them.
I would say one of the best skills in working with teams is just being able to understand where everyone's coming from. It's very rare that you get a team that is always on the same page. That happens very rarely in any profession, but being able to listen to other people and understand their perspective and also effectively communicate your own thoughts and opinions without, you know, discrediting others, I think that's a really, really strong skill to have.
So the job market in Saskatchewan is actually very good and has been for quite a while for engineering. We have a large mining sector that has been, you know, growing for at least a decade, probably more than a decade. And the industry that supports that industry has been growing as well. You go back 20, 30 years ago, or even 50 years ago when all the potash mines were built, a lot of that was all brought from Europe or United States. Now we tend to build all that ourselves. There's a huge construction and manufacturing industry in Saskatchewan that didn't used to be there, and it's still growing. So you can work for the constructors, you can work for the companies that are building the machines, you can be a guy that does maintenance, you can work for the teams that are doing installations, or you can work for the engineers that design it all in the first place. Or you can work directly for the companies. They all have engineers. They all need lots of support. So there's a variety of different places you can go, and arguably an insatiable demand for the skill sets and those skill sets aren't very specific. It isn't just, oh, we need mechanical engineers. No, they need all engineers, all trades. You know, it's literally any skill you can imagine, we likely need somewhere in our organizations.
I think if someone wants to get into engineering, there's obviously that hurdle of getting into post-secondary initially. I think with that, there's the hurdles of economic boundaries, but also, you know, you have to get a certain level of grades to be able to get into university. And I think a lot of people need to keep in mind that there are so many resources now that are there to help students get into careers like this. There shouldn't be any judgment in people accessing those resources. Scholarships, there's so many that are underutilized. There's so many scholarships that are underutilized. And if that's a boundary for students, I would highly encourage them doing research and talking to their counselors and teachers about different opportunities. For myself as a female in the engineering profession, I think I definitely came in with this perception that I would be a minority and perhaps not feel as included or as accepted in this industry as I do. And it wasn't until I started working at Hatch that I realized just how many movements are being made in engineering and the mining space to make equality a priority. There are no stupid questions. I'm sure that's advice a lot of people give, but it took me a long time to truly accept that and realize that that was a boundary for myself. That was something that was holding me back. And it honestly wasn't until university where I had friends that were too shy to speak up and ask their own questions, and I was asking questions on their behalf, that I realized, no, I'm actually learning so much more. And if you have a question, it's likely that everyone else does too. And we notice it in profession as well. We have students come in and they're too shy to say that they don't know something or to ask a question about something. And at the end of the day, it's so much more efficient and they are learning so much more if they feel comfortable doing that.
Figure out what your passion is first. Trying to figure out what your passions are is really important in making sure that your career is actually fulfilling to you. I was always pretty good at math and I really enjoyed science. I really enjoyed chemistry, geology, all of that. And so I ended up finding a career path that perfectly matched that for me. And it's not just that I like what I do, it's that I'm genuinely passionate about the work that I'm doing. And so it makes the days feel a lot, it doesn't feel like work. You know, if you do what you love, you're really never gonna work a day in your life because it doesn't feel like work anymore.